All right then, so now let's clean up this question and let's move on to the next question, which in case it's going to be find the factorial of the given number, right? So that's our question. So first of all, we need to understand what is the factorial of what is the factorial of a given number. So first we need to understand what is the factorial is, right? So let us say like this. So factorial of a number is the product of all positive integers from 1 to n. It doesn't matter one number is, let's say if I give 5, I need to find out the product of the number from 1 to 5. 1 into 2 into 3 into 4 into 5. That's the factorial, right? So let me show you how does it written. So let me bring it up over here so you can see it. All right, here we are. So this is how it does looks, right? So for example, let's say if I want to find out the 4 factorial, which in case it will be written as 4 into 3 into 2 into 1. So the result will be 2, 6, 24. So for factorial, the result will be 24. So now I hope you understand how the factorial will look like, right? So now let's write a program to find out the factorial of a given number, right? But in this case, we are not going to use any basic way. We are going to use the recursion, right? So yeah, so in the meanwhile, I will explain you what is the recursion is. So recursion is nothing but is nothing like a function call itself. It's called recursion. So let me show you. Let me explain it in a brief way. Um, just a moment. So the recursive function is a function that calls itself, as I said, right, either directly or indirectly to solve a problem by breaking it down into similar or self-similar subproblems, right? So basically it requires a base case, which is a condition that stops a function from calling itself infinitely, right? So that's it. A function calls itself again and again. So until we have a very specific conditions to stop calling it infinitely. Okay, so we're going to use that concept over here. So let me write that. For instance, let's say const find factorial, which is equals to arrow function, and that is going to be the number. So if the number is equals to, at the early point, if the number is equals to 0, I need to stop. Or if the given number is equals to 1 itself, I need to return the value as 1 itself. Return 1. Okay, so 0 factorial, basically 0 factorial, and if the value is equals to 1, we are supposed to return the value as 1. Else what I'm supposed to do, I just need to say return number multiplied by find factorial, again call the same function with number minus 1. Okay, and that is going to be returned, and at the end all I have to say console.log find factorial of 4. So let me run it, and that is going to give me the answer as 24. So let me give you a brief explanation what exactly we done over here. So we created a function, right, which takes a number as a function parameter. Then here we are checking if the number is equals to 0 or 1. This is the base case for the recursion. So the factorial of 0 and 1 is always 1. So that's the condition we are checking over here. So if the condition is true, then the function will stop calling itself, and it is going to return the value as 1 itself. If in case it's not, it is going to return this one. So at this point, what we are doing, this is the most case, the recursive case over here. The function calls itself with the number minus 1, right, and multiply the results by the number. Okay, and it's going to multiply the results with the same number. This will goes until the base case got terminated. Okay, how it is going to terminate? At some point the value will be reduced from 4 to 0, so the 0 will, by the end it's going to return 1. Okay, So let me give you an explanation. Let me break out the looping structure over here. How does it is going to break? So first, when you're sending a number with a function called find factorial, so what we are doing, we are calling this function with the value as number 4. Then it comes inside. So according to this, 4 is not equals to 0, 4 is not equals to 1 as well as, right? Then it is going to multiply, we're going to keep that number as 4, then into find factorial of number 4 itself. So from here it is going to start multiply with find factorial of number 4 minus 1, right? That is what is going to happen here. So which is in case 4 minus 1 will become 3. Okay, then it's going to call, it's going to get inside the value as 3, then 3 is not equal to 0 and 1 as well as, then it's going to come back and it is going to have the value as find factorial of 3 minus 1, 2. Then it's going to get inside as 2. 2 of course is not equals to 0 or 1, so it's going to find the factorial of 1. So then it's going to get inside. Okay, so this time it will comes inside as 1 and it is going to returns the value as 1 itself, which in case that is going to be our base case. So this is how the recursive functions it's keep on calling, right? So the for instance, let's say, so this 1 factorial is going to be 1, 2 factorial is going to be 2 into 1, so result will be 2, 3 factorial will be 3 into 2, which is going to be 6, so the result will be 6, and 4 factorial will be 4 into 3, 12, right? So at the end you just need to calculate those values. Okay, so if you separately calculate all these values, you will be get confused. You just need to add up all these values, 12, 6, and then you just need to keep on adding it. You need to add the results every single time. Okay, so yeah, so that is how this recursive function it's keep on working, and we are getting the output over here. Okay, so usually how it's get done, if you're not using these functions as a recursive function, you can write it like this: const factorial, which in case it's going to be take the numbers as the input, open it, and if the number is less than 0, I just need to negative number, return it as a undefined. So less than value 0, less than value will never be going to be there. And then I'm just going to say let result is equals to 1, because I'm going to store the result. So if I try to multiply with value with 0, it will become 0, so I can need to store it as a 1. So I'm going to use the for loop for let I equals to 1. Okay, I equals to 1, then I less than equals to number, then I plus plus, open it. So the result equals to result plus equals to result plus I. Okay, so that is why we return it as a result plus I. Okay, then I need to return the result. So if I try to do the same thing over here, I'm gonna get the same output. Okay, so we happen to have some issue that I equals to, oops, this is supposed to be multiplication symbol, that's why I'm wondering. There we go, see, it is not plus c equals to, because basically what we are trying to do over here, result equals to result multiplied with I. That is what we are trying to do over here. So let's say if we need to understand the differentiation between what is the difference between the recursive way and in the iterative way. Okay, so let's talk about the call stack. So recursive way grows with each recursive call, right? So the call stack will keep on calling again and again, so the call stack will keep on grows. And in iterative version, there is no extra stack of usage, so we are not calling it again because we are just iterating it. When it comes to performance wise, it's slightly slower for larger number cases, right? For 5, 10, it's not an issue, but when you're going with the larger cases, it's going to be have a performance issue. And compared to the recursive way, this iterative version, it's always faster and constant memory usage only. Okay. And the risk management, it will always takes a recursive some point, it will takes us to the stack overflow for a large number of n. And iterative way, it might feel slower, but it's more safer and more consistent for memory usage as well as, and for very large numbers it's safe. Okay, so you decide what you can use for your finding the factorial. That depends on the scenarios and cases. Okay, so yep, this is it. So now if you wish to have a single liner code for this particular one, we can do that. Okay, so but all we have to do, it's going to be quite complicated. You need to that for sure, that is going to be a quite complicated one. So let me show you how to write a find factorial for a single liner code. Okay, so I'm just going to say const single liner factorial, something like that, is equals to, I'm going to get the n inside. So if n is less than 0, what we are going to do, we are going to do it as return it as an undefined. Or else if n is equals to 0, then what I'm supposed to do, I'm supposed to return the value as 1. Or else what I need to do, I'm going to return it as an array so that I can multiply each and every value in it. Okay, so now I need to create basically what we are supplying 4. So if you try to find out the factorial for 4, we need to multiply 4 into 3 into 2 into 1. So I need to create an array, and then I need to access the each value in it. Then I need to find the calculation of it. So if I'm trying to find the factorial of 4, I need to get the values like 4, 3, 2, 1, right? So that's what we are trying to do. So create an array and use the spread operator and use the array itself. I'm going to create the number of array elements with the n value itself. Then I'm going to use the keys function over here. Okay, so that keys function returns the iteratable keys in the array so that we can access each and every element. Then I'm going to use the map function in it. Okay, then I'm going to access the I. Then I'm just going to say I plus 1. Okay, then I'm going to use the reduce function in it, which is going to access the a and b value simultaneously so that we can multiply it. Okay, that's it. This is how it's going to be. And now if I save this, this is how it does it look. Okay, so first what we are doing over here, we are creating a single liner function which takes the n, which is now in case it's going to be 4 as a function parameter. If the n is less than 0, we are returning as undefined, or else we are trying to check if the n is equals to 0, then we need to return it as 1. Or else what I'm trying to do, I'm trying to convert it as an array because we are trying to calculate. Okay, the reason why we are trying to convert it as an array, because array of n, because factorials, if you're trying to factorial for 4n, it's trying to fetch the value as 4, 3, 2, 1. We need to multiply like this. So in order to do that, we are creating the array of n values and we are converting it into the keys, because this gives you the iteratable keys in the array. Using then we are using the map function to access the each and element when we are adding it with 1, because array index always starts from 0, but I don't want to start the index from 0, but I need to access the values like 1, 2, 3, 4. So that's the reason we are accessing, because it is going to return the iteratable keys, not the values. Then we are using the reduce function, then we are accessing those, then we are multiplying it. Okay, so that's the reason we are using this gives you the sequence of the numbers from 0, 1, 2, 3, 4, right? So if you supply the values over here 4, then it is going to return you the value as 0, 1, 2, 3. We need to multiply it from 1, so we are adding it from I plus 1. That's the reason. Okay, then we are using the reduce function in order to do the complex calculations over here, because we need to multiply with all the elements. That's the reason. Okay, this is the thing. And now if I give you the same function over here, and if I run the same program, that is going to give me the exact same output. Which in case we have three different variations for writing a program for finding the factorial. So in the interview, if anyone asks write a program, to find a factorial of the number. So if they mentioned it in any specific instructions, use the for loop to find out, use the iterative way or recursive way, or use the modern JavaScript. So then you need to go for it, or else choose wisely, because the next question will comes from what program you written. Okay, so I hope you enjoyed this. So let's move on to the next question.